Hi everyone, it's Jason here and welcome again to Engineering Math for EE. So for this discussion, we will be discussing the following topics. Complex number. So this is just a review of your basic knowledge in complex number and its basic form. Then we will be discussing the basic operations involving complex number such as addition, multiplication, subtraction, and division. So let's go to the basic definition of complex number. By definition, a complex number z is an ordered pair xy of real numbers x and y written z is equal to x comma y. So x is called the real part and y is the imaginary part of z written x is equal to real of z and y is equal to imaginary of z. So complex numbers z is equal to xy are written x plus iy or x plus yi. But in electrical engineering, we have been using letter I in reference to current I. Thus, in the following slides, we will just be using letter J when we talk about the imaginary part of our complex number. So now let's go to the concept of addition. Addition of two complex numbers z1 is equal to the ordered pair x1, y1 and z2 is equal to the ordered pair x2, y2 is defined by x1 plus z2 is equal to the ordered pair x1, y1 plus the ordered pair x2, y2. Then we will just have to combine x and we will just have to combine y. Thus we have here x1 plus x2 plus y1 plus y2. So these two terms refers to the basic form of complex number, wherein the first term will be your real part and the second term will be your imaginary part. So say for example we have here z1 is equal to 8 plus j3 and z2 is equal to 9 minus 2. Then we have to find z1 plus z2. So we will just be using the concept we have learned from the previous slide, wherein z1 plus z2 is just equal to the ordered pair x1, y1 plus the ordered pair x2, y2. Then we will just be combining the x term and also the y term. Your x term as your real part and your y term as your imaginary part. So now we have to substitute the values for x1, which is equal to 8, and for your x2, which is equal to 9. Then the value of your y1, which is equal to j3, and your value of y2 is equal to negative j2. Thus, our answer here we have 17 plus j. Okay, to further understand the concept, we have here an example for you to solve. So say we have z1 is equal to 10 plus j5 and z2 is equal to 2 minus j8. Then all you have to do is to find the value of z1 plus z2. You can pause this video so that you would be able to have the answer for this exercise. For your reference, the answer would be 12 minus j3. Okay, so now let's go to the concept of multiplication of complex number. Multiplication is defined by z1 times z2 is just equal to the ordered pair x1, y1 times the ordered pair x2, y2. This equation here can be substituted and can be solved using FOIL method, which is very common in the mathematics. So you don't have to memorize this form. All you have to do is to apply the concept of FOIL method. So say for example we have here z1 is equal to 8 plus j3 and we have z2 here which is equal to 9 minus j2. So then we have to find z1 times z2. Okay, so first is we have to substitute the value for our z1 and z2. z1, that is 8 plus j3 times the quantity, the value of z2, which is equal to 9 minus j12. As what I've said, you don't have to memorize the form that was being presented a while ago because you can only apply FOIL just to get the answer. So first is you have to apply FOIL method, then you can have 8 times 9, which is 72, 8 times negative j12, which is negative j16, plus j27 minus negative 1 times 6. So your answer would be 78 plus j11. However, when it comes to the concepts of subtraction and division, we don't really have to discuss it further since subtraction is just the inverse function of addition and division is just the inverse function of multiplication. So say for example, we have here z1 is equal to 8 plus 3i and z2 is equal to 9 minus 2i. So then we have to find z1 minus z2. So first we have to substitute the values for our z1 and z2. We have here 8 plus 3i minus 9 minus 2i. So to simplify it further, we'll just have to combine the like terms. So the answer would be negative 1 plus 5i. Now if we are going to find the quotient of z1 and z2, so we have here z1 over z2 is equal to 8 plus j3 over 9 minus j2. So what happened here? Well, the concept is just very easy. Remember the concept of rationalizing the denominator to avoid complex form in the denominator. Thus, we'll just have to get the conjugate of our denominator. So in this case, the conjugate of 9 minus j12 is just 9 plus j12. Then apply the basic concept of mathematics and you will get the answer 66 over 85 plus j 43 over 85. So that would be the end of lecture 2.